difference between exponential growth and decay. So exponential growth occurs when a quantity increases by the same factor over equal intervals of time. So maybe it's always doubling or tripling or quadrupling. An exponential growth function looks like y equals a 1 plus r to the t. And with that, a has to be bigger than 0, so it can't be a negative number. And r also has to be greater than 0. And that r being bigger than 0 is really what's telling us that it is growing, because when we add it to 1, we get something bigger than 1. So we're multiplying by a bigger number, which makes it continue to grow. So if we look at this and kind of break it down into the pieces, the formula y equals a 1 plus r to the t. So y is the final or ending amount. A is your starting or initial amount. The 1 plus r, so that whole thing together, which is basically in the same place as b normally would be, that is called your growth factor. So if it's 2, it's doubling. If it's 3, it's tripling, and so on. The r itself is the rate of growth, or growth rate. And of course, that has to be put in as a decimal. And then t is the easy one. T is time. And that time can be in whatever you're dealing with. So if the problem deals with years, t is in years. If it's dealing with minutes, then t is in minutes. So when we want to deal with a story problem, we need to find that a, that r, that t, and find the different pieces so we can write our equation. So if we look and see what we've got here, we've got the inaugural attendance is 80,000. Inaugural means like the starting, the first. So that means that A, our initial amount, is 80,000. Okay, if we keep going, it says it increases by 6% each year. So that means the R, the growth rate, is 6%, but remember we need that as a decimal, so we'll write it as 0.06. Now, we need to write an exponential growth function after t years. So that's like leaving both x and y in there. We're going to leave t in there. So let's start with that part. So we know y is equal to 80,000, because that was our a, 1 plus 0.06, and we're leaving it as t, because we're just writing that initial function. So to simplify it, we'll have y equals 80,000, 1.06 to the t. And that is our exponential growth function for t years. Now, they do then ask us in the 5th year to the nearest 1,000. So, to find that, we're going to use the formula we just created and plug in 5 for t. So y equals 80,000 times 1.06 to the 5th. So, easiest thing here is to type that in your calculator. Type in the 1.06. Use the x to the y button. Put in the 5th. That'll give you some funky decimal. Leave it in there and then type times 80,000. And you end up getting y is approximately 107,058 people. So once we have that function, we can find any amount of y that we want.
I have 2 announcements. Number 1, please release the wrestlers for their match at Lewis and Clark.
So see if you can set this one up.
Please release the wrestling team for their Lewis and Clark match. Second, please release the reserve girls basketball team for their game at La Vista. Again, the reserve girls basketball team will be playing at La Vista.
So here we've got a website that has 500,000 members in 2010, and then it tells us that our time is years after that. So that means our starting point is 2010. So A is the 500,000 that we had in 2010. Our rate is 15%, which as a decimal is 0.15. And then for the second part where you know T is going to be 6, because 2016 is 6 years after 2010. So let's start by writing our equation. Y is equal to 500,000, 1 plus 0.15 to the t. Remember, we're starting by just that function, leaving t and y both in there. So we simplify it to 500,000, 1.15 t. So there's our function we're going to use. And for the second step, we're going to plug in that t equals 6. So 500,000, 1.15 to the 6. Remember, do that power first, just like order of operations. Take that result times 500,000, and you'll get y is approximately 1,156,530. But notice it said to the nearest 10,000. The 10,000 is right here. So we're going to round this to 1,160,000 members. So make sure that you always are checking to see where you are supposed to round to. Now, exponential decay is very similar to growth, you're going to see. The difference is that it's when our quantity decreases. So something like half-life, where it's constantly getting cut in half. So our formula is y equals a, 1 minus r to the t. And you might think that looks pretty similar to our exponential growth, and it's because it is. The only difference is instead of adding r, we are subtracting r. Then a is greater than 0, and 0 is between r and 1. So we can't subtract away more than 100%, and we can't subtract away a negative number, because then it just becomes growth. So our r always has to be between 0 and 1. So in that formula, just like before, y is that final amount, or ending amount. A is the initial, or starting amount. R, in this case, instead of being growth rate, or rate of growth, is our decay rate, or rate of decay. And like before, we need to put it as a decimal. T is still our time. And when we combine the 1 minus r, that part is our decay factor. So the r itself is the rate, but the 1 minus or the 1 plus is the factor. Okay, so let's see what information we can find here. After a blizzard, there's 19 inches of snow. So that's where we are starting. So A is 19. They tell us it melts, so we know it's decreasing because it's going down, at 3%. So R is 3%, or 0.03. So we're going to write our function first off. So y is equal to 19, 1 minus 0.03 to the t. So make sure this time that you actually subtract. 1 minus that means I should get something smaller than 1. That's how we know that it is decay, because that thing in the parentheses is smaller than 1. So there's our function. Now we want to know how much snow there is 1 week after our blizzard. But our rate was each day, so we really need to convert that week into days. Well, there's 7 days in a week. So we plug in 7 for t. Do the exponent part first, and then multiply it by 19. and we get about 15.35 inches. And when you're doing these story problems, if something is growing, getting bigger, increasing, you should end up with something bigger than A. When it's decreasing, or in this case, melting, going away, you should end up with something smaller than what you started with. 15.35 is less than 19, so we're good. Okay, so now we need to decide whether it is exponential growth, exponential decay, or neither. So, the way you can tell is if we are multiplying by something bigger than 1. Then that tells us it's growth. If we are multiplying by something less than 1, that tells us it's decay. Anything else is neither. So, if we just put this into a table really quick, like an XY table, so X is there, Y is here. I've got 0, 64, 1, 16, 2, 4, and 3, 1. So my X's are all going up by 1, so we're good there. Then we want to look at what are the Y's doing. Well, it's dividing by 4. But remember, we want to know what we're multiplying by. So dividing by 4 is the same thing as multiplying by the fraction 1 over 4. Since we are multiplying by something less than 1, it is exponential decay. Okay, let's look at this next one. Same kind of thing. I'm going to make my little table, put my X's and Y's into it. And this time my X's aren't going up by 1, but they are all going up by 2, so that's still consistent, so we can still look at the Y part. And it doesn't look like we're multiplying anything, but we are adding 7 every time. Since we're not multiplying by something, we can just put neither. It has some kind of relationship, but it's not exponential growth or decay. Okay, why don't you try these two, see how you do, and then come back and check them. So in both cases, our X's are just going up by 1, so that's good. Now we need to see what we are multiplying by. So in the first one, it looks like everything is getting cut in half, or divided by 2. So that means we are multiplying by 1/2. We're multiplying by something smaller than 1, which means it is exponential decay. On the second one, we can clearly see the numbers are getting bigger, and in fact, we are multiplying by 10 every time. So we're multiplying by something bigger than 1, so it is exponential growth. So multiplying by smaller than 1, decay. Multiplying by bigger than 1, growth. Anything else, it's neither. There is your homework. Go ahead and get that done.